We're going to start our unit on exponential and logarithmic functions. And so today we're just going to look at an intro of solving exponential functions. And for all of these, we want to use no calculators today. All right. There are times when we will be able to use calculators, but today, because we're just starting the intro, we want to be able to do everything without a calculator and use a rule. And so you have this rule, or we call it property. And what that says is that if you have like bases, right? So if I can write something where the base values are exactly the same, since this is an equation, then what that means is that the exponents must be the same. And so what I can do is I can set just the exponents equal to each other and solve. The other thing is that if I have two equations where I can make exponents equal, then I can write them to where then that must mean that the base values are also equal. And so what we do is we have this arrow going kind of both directions to show that you can use the property both ways. Either make the bases the same so you can solve when the exponents will be equal to each other, or make the exponents equal so that way I can solve the base equation. So we're going to look at just a couple of examples. Right. So let's look at all these we want to solve for x. And so we're going to have a base of 5 raised to the 3 minus 2x power. And that is going to be equal to 5 raised to the negative x power. So exponential functions, or exponential equations, these are equations where the variable is as an exponent. Right? That's what it means to be an exponential. And so what I want to be able to recognize is that the rule that I have is that I have the bases already the same. And since my base values are the same, the only way this side of the equation can be equal to that side is if I set my exponents equal to each other and solve. And so that's what I'm going to do. I'm going to write this equation down, and now I'm going to solve the equation like I normally would for any equation. I'm going to bring my variables to one side. Right. And so for these two equations to be equal to each other, these two expressions, I would need to have the x to be equal to the value of 3 to make that happen. You're not required to plug it in and check, all right, but they would give you the exact same value. Right? And that's your process. All right, so let's just look at a few. Just going to need a variety here. Let's do some where you have a little bit of extra work that you have to do first. Right? So, for example, let's say you have, I don't know, 4 to the 5x minus 1, and I want to set that equal to 8 to the 3x. Now, in this case, your base values are not the same. And so what you need to do is you need to be able to manipulate the bases using rules of exponents to be able to make that the same. And so I'm going to kind of go off to the side here. And you need to remember what it means, how I write 4. All right, so between 4 and 8, you have to bring them both down to a lower base right now, because there's no way that I can take like a small, like base 4. So the number 4 is the same thing as 2 squared. Right? And so all I'm going to do is I'm just going to modify 4 and write that as the smallest base raised to x exponent. And this 5x minus 1 is still the exponent. And so what you're doing is you're using some rules of exponents, and you're leaving the current exponent on the outside, and you're writing 4 as a base to a power to make sure that this is actually the same thing as 4. Then you're going to do the same thing for 8. 8 is the same thing as 2 cubed. And then I still have this 3x on the outside. All right, so what you're going to need to notice is that the exponent that's on the outside is still there, and all you've done is rewritten what the base looks like. So the base of 4 is the same thing as 2 squared, and base 8 is the same thing as 2 cubed. So I've just rewritten the base. And what I've done is that now they both are the same base. All right, so they both have a base 2 now, so that makes this rule the same. And then what I'm going to do is I'm going to write everything that's in the exponent now as an equation. So the 2 that's sitting here, I need that 2, and the 5x minus 1. I need all of the exponents written down to set my equation, because that's what the rule is. Whatever the exponents are gets written as an equation. Same thing here. The 3 on the inside, that was from writing 2 cubed, times the 3x on the outside. All right. And so I want you to see that this 2 and this 3 were from the exponents that came from the inside here, and the other piece is the remaining exponent. Right. And so your main strategy right here is going to be rewrite the bases, right, to be the same. All right, that's going to be the first strategy. And then we can set the exponents equal to each other and solve. All right, so now I'm going to need to distribute. So I'm going to get 10x minus 2 equals 9x. All right, and I can solve this in any way that I want. Again, if I bring the 9x to this side, I can bring the 2 to the other side at the same time. And I'm going to get x equals 2. All right. So again, for this initial or the original equation to be equal to each other, I'm going to have to write those as like bases. Now let's look at just 2 other. Some of them are going to use concepts that you haven't talked about in a while. For example, I have 2. I'm going to write this to the x squared plus 4 power. And that's going to be equal to 2 to the 5x. And now the problem that I can see right off the bat, I know that these have like bases. That's great. But when I set my exponents equal to each other, I have a quadratic. And typically, when you haven't worked with quadratics in a while, right, you're going to have to look back and see what it is that we do with quadratics. So with a quadratic, the first thing we need to do is put all of the terms on the same side and set this equal to 0. Right. And then we want to be able to use the zero product property, which means that I need to factor. Right. And now again, you're going to have to remember when do you use factoring, kind of what your process is. So way back when, if a here is 1, right, and that's a good thing because it kind of saves us some time. Right. This x squared, I'm going to put 1 in each of these boxes here. And now I'm looking for the product of 4 that has the sum of negative 5. And so it's always the product of the last with the sum of the middle. So 2 numbers I can multiply to get 4 that are going to be positive but apt to be negative is going to be a negative 1 and negative 4. And then I need to set both of these equal to 0 and solve. So either x minus 1 is 0 or x minus 4 is 0. And so the 2 values that actually make this work are always when x equals 1 and 4. And both of those values make the original equation true. And so you're not always going to have something linear. Right? This is considered a linear equation when x is to the first power. You are going to have some of these quadratic equations come up where you're going to need to review and go back and see how am I going to solve that. Okay. And now your final type is going to be something where instead of the bases being equal, right, your exponents are going to be equal. So for example, 2x minus 1 raised to the 5th power is equal to a negative 32. Right. Since this is a binomial, there's no way that I can rewrite this to have the same base as that. So my plan is actually to modify this side right here so that way the exponents are going to be the same. All right, and so when I do that, I'm going to leave this 2x minus 1 to the fifth. But now I need to think about a number that I can raise to the fifth power that's going to give me 32. And since this is an odd number right here, that's going to keep my value negative. And you can check that in the calculator. But you usually check values of 2s or bases of 3s and 5s. Small bases, 2, 3, and 5. Right. But again, now the rule is basically going backwards. Right. So now what I've got is I've got my exponents are equal already. Right. And so if my exponents are equal to each other, then that means that I can set my bases then equal to each other and solve. All right, so this is still considered an exponential function. All right, I have an equation, even though the variable is not in the exponent. All right, this is still considered an exponential function for what we're working with, to use the rule backwards. So I'm going to set this bases here equal to each other and solve. So I'm going to add 1 and then divide by 2. All right, so if you come up against ones where you have a set of parentheses with a binomial or even a trinomial, anything that's not just one term raised to a power, you're going to have to use the rule kind of in the reverse order.